Welcome to part 2 of 8.2, substitution method for solving these systems of linear equations. So we're going to continue down with this problem here. Now, if we look at the first equation, we need to solve this for one of the variables, either x or y, to use that substitution method. And if we solve the first equation for x, we're going to have to divide by 3. Well, 2 and 1 are not divisible by 3, so that'd be bad. If we solve the first equation for y, we'd have to divide by 2. Well, 3 and 1 are not divisible by 2 either, so maybe we should look at the second one. Now, looking at the second one here, if we solve for x, we divide 5 and 5 by 5. That looks like a good deal. So I'm going to use this first one, 5x minus 5y equals 5, to solve this for x. So first thing to do, we're going to add 5y to both sides. We need cancellation here, so we get 5x equals 5y plus 5. Then divide everything by 5. And we get x equals y plus 1. So, because we used the second equation to solve for x, that means we're going to plug this back into the first equation. Now, because we've isolated the x, wherever we see the x, we can write this y plus 1. So we can write 3 times y plus 1 minus 2y equals 1. Now it's time to solve this. So now we distribute here 3y plus 3 minus 2y equals 1. Combine like terms, our 3y minus 2y is just y plus 3 equals 1. Subtract our 3, and we get y equals negative 2. So, as an ordered pair, y equals negative 2. Now to find our x, we can plug this back into any y we see, but it's easiest to plug it in this one because we've already have x isolated. So here, if we plug this back in, we get x equals negative 2 plus 1. So we're plugging this back in for that y right there. So x equals negative 1, negative 1, negative 2. That is the solution we're looking for right there. Okay, so the next two, it looks like we have a couple story problems. So story problems are going to just read through and see if we can get an idea what's going on with these. Now, first one says the perimeter of a soccer field is 340 meters. So soccer field is rectangular, so you have a length, a width, and a width. So the perimeter is 340 meters. So the perimeter of this would be 2 lengths and 2 widths. So that'd be the distance to go all the way around, width, length, width, length. So 2 lengths plus 2 widths equals 340. So the perimeter is 340, so we can say that. Now, it says the length exceeds the width by 50. So the length is longer than the width, so the length exceeds the width, so it's 50 more than the width, so we can say L equals 50 plus W. So right here, the length exceeds the width by 50, so if we add 50 to the length of the width, that will be the length. So our two equations we have is 2L plus 2W equals 340. That's the perimeter of this soccer field. That's what we're getting there. The length exceeds the width by 50 feet. That's giving us L equals 50 plus W, or we could write that as W plus 50. Now we're trying to find the length and the width of this field. So, because we already have this isolated for L, we can just substitute this 50 plus W in where we see that L right there. So we have 2 times 50 plus W plus 2W equals 340. So 2 times our 50 is 100. Distribution over here gives us plus 2W. Plus 2W equals 340. So 100 plus 4W equals 340. Subtract our 100. So we get 4W equals 240. And divide both sides by 4, and we get W equals 60. So that tells us the width is 60 meters. So the width is 60 meters. Now we need to find the length as well. Notice the length is 50 more than the width, so by plugging the 60 into here, we get L equals 50 plus 60. So the width is 60 and the length is 110. So the length is 110 meters. So the width is 60 meters, the length is 110 meters, and we're good with that problem there. So Next one we're talking about, we're doing some airplane seating. So an airplane is 152 seats. The number of coach seats is 5 more than 6 times the number of first class seats. How many seats are there of each type? Well, first we want to define our variables. They're coach seats, so let's let C equal the number of coach seats. And let's let F equal the number of first class. Okay, so if there's 152 total seats, that would mean that the number of coach plus the number of first class is 152. So you can say C plus F equals 152. So total number of seats is going to be the number of coach plus the number of first class. Now it goes on to say the coach seats is 5 more than 6 times the number of first class. So we can say, we can do almost a direct translation here. Coach C is means equals 5 more than. Well, 5 more than, we're adding 5 to something. But what are we adding 5 to? 6 times the number of first class. So if F is the number of first class, 6 times the number of first class, 6F. So these are the two equations that we come up with. And when we're doing story problems in the system section, we need to have these two equations because we have two variables. So because C equals 6F plus 5, we can do a little substitution and plug that in for the C right there. That is, we can write this as 6F plus 5 plus F equals 152. So combine these up, 6F and F is 7F plus 5 equals 152. Subtract some 5s, and 7F equals, excuse me, 147 divided by 7, and we get F equals 21. So we know there are 21 first class seats. So there are 21 first class seats. Now, that's how many first class seats. We need to know how many coach seats there are. So what we can do is we can plug this in for our F in this equation right here and solve for the C. That's the number of coach seats. So plugging that in, do some blue. C equals 6 times 21 plus 5. Or we can note that there's 152 total seats and take the 21 away from that. Either way, we're going to get the same answer. So see here, 21 times 6 is 126 plus 5. This gives us C equals 131. So there's 21 first class seats and there are 131 coach seats. So that is that one right there. So hopefully this made sense, and we'll see you next time for the elimination method.